Hey guys, Mr. Bowman here. The learning objective of this video is in yellow. We are learning to differentiate given functions. And what we're going to do is we're going to step through what the definition of differentiation is, how the notation for derivatives or differentiation works, and we're going to go through some formulas and examples. So the first thing we need to be aware of, what exactly is differentiation? So differentiation, what is it? And for me, it's the process of determining the gradient function of a given function. So we did chat about gradient functions in an earlier video, but what that means is you're given a function, let's say it's a cubic, and your job is to come up, well, if you were to map or track the gradient at every point in that function, what would that be? And that might look like a parabola. So our job is to come up with a gradient function of our original function. And there's lots of different ways. I'm just going to change pen colors for this bit. We'll switch to green. In terms of notation, typically y can be the function. So y equals 3x plus 5. That could be a function. And if you were to differentiate y and come up with a gradient function, you'd be calling it y dash. So that's the gradient function. There's also two other ways that this commonly gets referred to. So I've just changed pen colors again. You may have called the function fx, in which case the derivative or the gradient function will be f dash x. And then finally, we'll change pen colors again. You may have y. Get rid of that. And the derivative function, it may be referred to as dy dx. So that's a quick intro. What is differentiation and what does it look like? So the next step that we want to go through is we do want to have a look at some formulas that are relevant for this. And then once we've gone through the formulas, we'll then have a look at 5 or 6 examples of how to apply the formulas and how to differentiate the functions that we are given. So let's start having a look at our formulas. So the main formula we need to be aware of. So these formulas will be in pairs. We'll be given the formula of the function and the corresponding formula of the derivative. So we're looking at polynomials. And if you're not sure what that means, that's ones like x squared or x cubed, x squared, x. It's just x to the power of something. So they're polynomials. So if your polynomial looks like this, a times x to the power of n. So we've generalized this formula. That means the derivative of y will be equal to a times n, x, n minus 1. So what this is meaning is we move the power to the front as a multiplication to get the na, and we then reduce the power by 1, n minus 1. And we'll get into some examples. So that's the first lot of formulas. The next lot of formulas, if x is a constant, the gradient there will always be 0. Because if you think about it, a constant would mean it's a straight line. And there's no rise or run here, so that gradient would just be a 0. And the final formula we need to be aware of, for example, maybe you've got y is equal to 2x plus 3 or plus 2. There's 2 parts in that formula, not just one. So we just need to figure out how do we deal with it if there are multiple parts in the formula. So let's say fx is equal to gx plus hx. So this is just part 1, and that's part 2 of the given function. F dash x, what we simply do is we differentiate g by itself, and then we're going to add the derivative of h. And obviously, if this was a subtraction sign, your one below would be dealing with a subtraction sign. So hopefully you found the introduction relatively useful. We haven't got into any differentiation yet, but hopefully you found it useful. What I want you to do, please pause the video, make sure you jot down the notes and the key formulas that we're going to be looking at. And what I'm going to do is I'm going to pause the video, I'm going to clear all of our working, and we're going to just get into some examples. How does this work? And I'm going to leave the formulas there on the right-hand side for us to refer back to. Okay, guys, we're back. Hopefully you got down the notes from before. So let's get into some questions. So let's say y is equal to 6x squared. How would we differentiate that? So I'm going to write y dash is equal. That's my notation that I'm looking for. And I suppose our starting point is this formula at the top, which would be our main formula. So hopefully you can see the a up front. That represents the 6 in the equation. And hopefully you can see the 2 up the top as the power, and that represents the n in our equation. So what we're going to do is we're going to go n times a. So we're going to move the 2 to the front. So that's going to become 2 times 6. And then we're going to reduce the power by 1. X 2 minus 1. So I'm just showing full working. Eventually we'll take shortcuts and do this in our head. And that then means y dash, or is equal to y, also 12 x to the power of 1, which we can just ignore that 1. So 12x would be our derivative of that. So let's have a go at another example. Let's say there are maybe 2 functions, like this formula down here. So if we'll change our notation to fx as well. So if fx is equal to 3x to the power of 4 plus 2x, what would the derivative of that be? So we have multiple parts, so we're looking down here. The first step is to differentiate g, or the first part of our formula. So let's do that. So f dash x is equal to, we're going to do the number out the front times the power. That's going to become 12. And then we're going to reduce the power by 1. So 4 goes to 3. That's x cubed. We're then going to do the same for the next function. So that's h. So we're going to look at h, and we're going to differentiate that. And that's 2x. So the key thing is, a lot of you are going to be like, oh gosh, there's no power here. There actually is. Mathematicians are just lazy, and I've missed it. So that power is secretly to the power of 1. So what we're going to do is we're going to go 2 times 1, or a times n. So that becomes 2 times 1, which is just 2. And we're going to reduce the power by 1, which becomes 0. And at this point here, I just want to remind everyone, I'm just going to probably write it on the useful formula side. X to the power of 0 is equal to 1. So that again becomes 2 times 1, which is just 2. So when we're doing this type of question, it will be 12x cubed plus 2. And a lot of you may have figured out, if it's just an x by itself, what you can do is you can actually just ignore that, and you'll get the derivative. So the x without a power, that comes 1, and then we don't need to do that. Okay. So let's have a look at 3. Let's do y. So y is equal to 2x cubed plus 4x squared plus 3. Or actually, let's make this harder. Let's go 6x plus 3. So we've got a big equation that's got 4 parts. And what we're going to do is we need to use this formula down the bottom. And we're going to differentiate each part individually. So let's use dy dx notation, this form. So all the notations are valid depending on what you're been given. So 2x cubed. Sorry, my hair's getting in my face, but 2x cubed. Let's go through our formula at the top. We're differentiating each part individually. So we need to go n times a. So 2 times 3 is 6. And then we need to reduce the power by 1. And that gets the 3 all the way down to a 2. We then need to differentiate the next function. We've got 4 times 2. Well, that gets us to 8. And we're going to change the power. That's going to become 1. And I'm just going to put an x there because we don't need to write x to the power 1 because that's just x. Okay, plus 6. Well, plus 6, this is similar to the one we looked at above. It doesn't have a power, which means it's to the power of 1, which means when we reduce it, when we do n minus 1, that's going to become 0, and we're just going to ignore it. So what we're going to do here, our differentiation, we're just going to ignore the x, and that's going to become 6. And the last part, we haven't looked at this one here, plus 3. Well, 3 is just a constant, so that's what that means. So 3 is just a number by itself. When you differentiate a number by itself, we ignore it. That becomes 0. So again, we'll scribble that out as well. And that means our derivative, dy dx, is equal to 6x squared plus 8x plus 6. So that was the first 3 questions. What we're going to do, we're going to do 3 more questions. I'm going to pause the video. So if you haven't got these examples and they're working down, please do. I'm going to pause the video. I'm going to clear our working. We're going to get into some harder questions, including fractions. Okay, so we're back. I've switched to the green pen, so we're now going to do question 4. And we're going to do 3 harder questions. So I'm just going to write an example down. So we've got x plus 1, x plus 4 in brackets. And the thing I'm concerned about here is there's no powers and there's multiplication. And what I'm concerned about is our formula down the bottom relies on us either adding or subtracting all of the components. So this is multiplication. We're not going to learn about multiplication in this video. We need everything to be adding or subtracting to each other. So before we start, we're actually going to expand this bracket. So that's going to become x squared plus 5x plus 4. Now that we've done that, all of a sudden it looks like this one at the bottom. There's x squared, which is gx, 5x is hx, and there's even another function 4 down the bottom. We're then going to differentiate that by itself. So we're going to go a times n, and there's an invisible 1 out the front of the x there. So that's going to be 2 times 1, which is 2. And then we're going to reduce the power by 1. That's going to become x to the power 1. And I'm going to ignore that 1 because I don't need that. We're then going to differentiate 5x. So that's x to the power 5x to the power 1. We're going to go 1 times 5. That stays at 5. And the 1 is going to become x to the power of 0. And as we remembered, we've written it down the bottom. That becomes 1. So we can just ignore the x to the power of 0 part. And finally, we need to differentiate 4. Again, 4 is a constant. It's a number by itself. If you differentiate that, you're just going to get 0. So we can write plus 0, but we know mathematically that can just be ignored as well. So our derivative of x plus 1, x plus 4 in brackets is 2x plus 5. And this is going to be our final question for today. It's going to look a bit nasty, and a lot of us are going to be concerned about it. Or actually, this won't be the final one. We're going to do a small one and then our big final one. So how would we differentiate x cubed divided by 6? So a lot of us are going to panic. We're going to be like, oh gosh, we're going to have an issue identifying the a value up top here. And my suggestion is, let's make our life a bit easier. Let's convert this to a fraction. So x cubed divided by 6, well, that's the same as 1/6 of x cubed. All of a sudden, we've got an a that we can work with. So let's go y dash. Well, that's going to be 1/6 times the power. So 1/6 times 3. And then x, and then the power is going to be reduced by 1. We now need to simplify the number out front. Well, that's going to become 3/6 of x squared, which will become 1/2 of x squared. And you may even simplify that again, x squared divided by 2. Divided by 2. So I have written into our formulas, but there we go. That would be our final answer. So lots of simplifying to do there. Sorry about the pausing of the video heaps. I'm having issues with the pen, but it looks like they're all resolved. And the final question, fx, we're going to get into fractions now. So let's say you got 2x to the power 4 divided by 3 plus 7 over 4x squared minus 3. How would we go about that? Similar process to what we just did above. Our a value is going to relate to the fraction of each of those components. So for the first component, our fraction is 2/3. So we're going to go 2/3 times 4. So that's the fraction times the power, or a times n. That's going to be multiplied by x to the power of 3, because the power is dropping from 4 to 3. We're then going to add 7 over 4 times 2. So that's a times n for this one. The fraction is 7 over 4, and the power is 2, hence 7 over 4 times 2. And that's going to then be multiplied by x, because x squared is going to become x1, which is just x by itself. And that minus 3, well, that's a constant, so that's going to become 0. So we can tack on the plus 0 if we want at the end, but eventually we're going to ignore that. And we can finish up our working down the bottom. So x4, so the 2 divided by 3 times 4, well, that's going to be 8 over 3. So let's get that down, over 3, and that's going to be of x cubed. So that is a funny 3. The next part, we're then going to add, well, that's going to become 14 over 4. So it's 7 times 2 gets us to 14 divided by 4 of x. And that plus 0 at the end, we're going to ignore that. So the derivative of our initial function, well, that's going to be 8 divided by 3 x times x cubed plus 14 over 4 times x. And just realize we can simplify that fraction at the end. So that's going to be 8 over 3 x cubed plus 7 over 2 times x. So I just simplified 14 over 4 to 7 over 2. So this was a very brief or very quick introduction into what is a big topic, differentiation. Hopefully you found the video and the notes useful. If you haven't, please go back, make sure you get the notes, make sure you get the examples down, make sure you understand every question step by step. Once you're happy with that, let's get into some questions. Thanks for listening, guys.